Hey, it's Mr. K, Chemistry 30, Unit B review. Numeric response number 10. Match the numbered Petri dishes shown on the table to the colors after the addition of the ferroxyl indicator. So for once, we get to read the information above like it's actually important for us. Here it goes. The ferroxyl indicator turns blue to indicate Fe2+. There's also phenolphthalein, which turns pink or dark purple in the presence of hydroxide ions. Okay, we have some information. Now we can roll. Here's what we have to do. We're going to look at each of these reactions, and we're going to determine what is going to react with what. Now, in all of these cases, it turns out that H2O and O2 are my strongest oxidizing agents. If we look at the table, we can see that H2O and O2 are quite a strong oxidizing agent, and now everything else will be below and to the right if we expect a spontaneous reaction. So in the first one, we have just an iron nail. Now with just an iron nail, what's going to happen is that's going to be my strongest reducing agent right here, and it's going to oxidize, meaning that I'm going to produce Fe2+ ions. So because I'm going to produce Fe2+ ions, that indicator is going to turn blue. Now, because my SOA, oxygen and water, produce hydroxide ions, anytime they are the SOA, I'm going to get hydroxide. So just for the rest of it, so you can see, everything turns pink. And that's because the H2O and the O2 form the strongest reducing agent, which produce hydroxide in each reaction. Okay, on to the second one. Why doesn't this one turn blue? Well, I have iron and zinc this time. And if I see iron and zinc, again on this side, iron is here, zinc is there. Zinc is a stronger reducing agent, meaning it will react before the iron. This is an example of a sacrificial anode. This is something we can put in, stronger reducing agent that will react instead of the iron, and it could act to protect the iron. Okay, looking at the third. Now this is iron wrapped with copper. Okay, so iron, copper, same SOA as before. This one will go blue and pink. So here's the problem. I've got copper way up here, and then I'll have to have iron down here. So iron this time is the stronger reducing agent. Copper is the weaker reducing agent, meaning the iron will react. I will produce Fe2+ ions. Okay, so copper is not doing anything to protect it. It's just sitting in there minding its own business. Okay, for the last one, iron nail and chromium. If I come back, I've got my iron, I've got my chromium. Once again, just like zinc, chromium is stronger reducing agent than iron. So chromium will react first. And the result of that is we don't get any blue ions. So in both these cases, when iron was the strongest reducing agent, it reacted and produced blue. When zinc and chromium were stronger, it acted like a sacrificial anode. It protected the iron, and the iron didn't react, so we didn't get the color blue. So then my options are, for pink, 2 and 4, for blue, 1 and 3. I would have accepted any of these combinations. Thanks a lot for tuning in.